Hi, everyone. I'm Stefan.
And I'm Safia, and we are both engineers on the ASP.NET team here at Microsoft.
And we're excited to show you the magic behind minimal APIs, which were introduced in .NET 6, and we've really done a lot to kind of improve the experience in .NET 7. And this is going to be a 400-level course. That's the idea, like a developer deep dive. So we're going to try to get into the guts of how it's implemented, hopefully give you a better understanding of how to use everything. So if you want to see some of what we're working on, we commit to the main repo because we're ASP.NET developers. There's an Ignite-demo branch. Might not be there long. We'll try to come up with a better long-term link. But if you guys are watching live, that might be there. So even though this is a 400-level course, I want to give everyone a bit of a refresher. People in the room, if this is not zoomed enough for you, please tell me. But this is straight out of our middleware docs. And I think we have some moderators who might have a link to this too that can help in chat. So middleware, I like to compare it to a Russian nesting doll of basically functions, right? And what middleware can do is it's a func of request delegate to request delegate. And what that means is that it takes a parameter, which is like the next middleware in the pipeline, right? And you invoke it. And then this whole time, to talk a bit about what a request delegate is, we're talking about a delegate type, which is defined like a delegate, and it just takes HTTP context, returns a task. So if you're used to maybe some other web frameworks, there's like certain named points in the pipeline, or maybe even like older versions of like system web, where you play like, okay, this is the authentication stage, and like this is the caching stage and all that. But here, when you're adding middleware, it's strictly based on the order that you call something, like use routing, use auth, use output cache. These are some of the new middleware that we've added. So in .NET or ASP.NET Core 3, we introduced the concept of endpoint routing. So before that, this, again, if you can see my cursor. So that little middleware diagram is straight from our docs. This, you can kind of tell I created an Excalibur. But this shows the default middleware that is added by web application in minimal APIs. So at the very start of the pipeline, if you don't do any extra work, we call a use routing middleware. You might have seen this in the older templates. It disappeared, but it's still there. And that's what's doing your route matching. It uses a DFA matcher. That's not the pluggable part, but it's kind of cool. Like, it uses a lot of memory, but it's really fast. Deterministic finite automaton, right?
That's what DFA stands for.
Yes, 400 level, we told you. And I know, you probably learned it in CS 101, but hey, it's advanced for us. It's nice when you get to use like computer science concepts in your day job. So then once we've matched the endpoints, right, there's usually some sort of like controller action or request delegate, right, that we just showed you earlier that actually handles like the terminal handler for the request. So there's eventually a middleware that just doesn't call next, right? It typically writes to the response body, and then that kind of locks down the HTTP context, right? Like at that point, if you've ever gotten an error, like you can't change headers now, right? Like that's not a specific stage in the middleware pipeline. It's just based on like once middleware starts flushing the headers or writing the response body. Like, that's how it is. Like that's a big difference in ASP.NET Core is there's a lot less buffering unless you plan to use that. So the advantage of basically doing the route matching before most of the middleware that you would add manually is that this allows things like use authorization, use rate limiting, use output cache to look at the metadata on the route. So what this means is if you have like require authorization on your endpoint, you call like map-get.require authorization, or you just add an authorized attribute, right? Like those are all things that this middleware can expect. And the way that happens is use routing basically will look at a list of endpoints that are defined using endpoint data sources. So this is like where the magic happens in little APIs. And if you click on this link for endpoint routing, this is our docs, and there's I'm not going to go in and read that, and this is super zoomed in. But like I noticed when working on this that it recommends for library authors, instead of calling like mapget or creating a custom controller, if you want to create endpoints in the library, like maybe you should create a custom endpoint source. But If you look at, say, grep.app or something, I've noticed that like outside of our repo, there's like maybe 5 that are open source. So that's like why I'm excited to show you what it's about and what it's capable of. And let's take a quick look, right, at what this looks like in the repo. So what we have is inside of use routing, we add middleware in the typical way you would. So we have this whole generic thing. And then what it ingests in routing is, apparently there's more than one place I can do this. Sorry. So anyway, what that's doing is it's basically going to look at this endpoint data source type for endpoints. So pretty simple class, right? It's an abstract-based class, and the most important member that you're going to have to look at is this endpoints member, and it's a read-only list of endpoint. You can implement this yourself. So quickly, what's an endpoint? Endpoint defines a request delegate. So unlike middleware, there's no func of request delegate because you can't call next. Like if you defined an endpoint, like you're not calling next. Typically, if you were going to call next at the end of the pipeline, you would get 404. So when there's no endpoint matched, use endpoints will call next. When there is an endpoint matched, the endpoint middleware will call hbcontext.getEndpoint, which will find the matched endpoint from the data source, right? The routing middleware already matched it, and then run the request delegate. So you might notice, if you're looking like really quickly at this type, this is the whole type, not very big. There's no route pattern, so how do you match it? And the secret there is 99.99% of endpoints are route endpoints. And that is how you define a route pattern. And this is generally the kind of strings that can take route values. So if you did like, this is not the right place to write it, but right. So if you could do like, my thing ID, right? Like that's a pattern. You can do regex and stuff too. There are constraints. It's cool. You should look at the routing docs. So really quickly, just to show you how this all goes together, I'm going to take what's basically the new empty web template, but it's like in our repo. And we can see how something like mapget uses this, right? So when you're adding middleware, right, there are basically 2 key types that the web application implements. It's iApplication Builder, right? And that's what runs the iMiddleware pipeline. So if we take like a really quick look, I told you I went over on time, and like so I'm trying to cut this down like in rehearsal. So we'll see how that goes. But anyway, this is what's basically taking those funcs of request delegates, which are then stored inside this like components list, right? And then it takes a 404 middleware, like Russian nesting doll, like I was talking about, right? So you can see this is a request delegate. This is the 404 middleware. And then, it's setting the status code. It's also checking, like, if you didn't call use endpoints, just in case it's like, oh, there's an endpoint, and then you never called use endpoints to, like, run the thing instead of the 404.
So this 404 middleware is basically the terminal middleware.
Exactly. And then we're working backwards from that, right? So we start, like, with the innermost part of the Russian nesting doll. We work our way backwards, right? You see the minus minus. So really, like, the last middleware you add gets added first, but that's because you're like building the Russian nesting dolls like inside out, right? So without further ado, that's not what mapget's doing though, because the use routing, use endpoint middleware is already there. That's where the stuff goes. So this is just adding an endpoint. It's not adding middleware. So if we were just like F12 through this in our repo, keep going, and eventually you'll see the magic where it basically adds a route endpoint data source. And we'll talk more about that in a sec. But just to see, like, okay, could I do this myself? Let's try it. This is the live coding session. So if this, you saw what happened earlier. So if this like fails at all, I'm gonna move on. But we're gonna try a custom endpoint data source.
Live implementation of an endpoint data source. This is a very brave act you're seeing.
I did it in rehearsal. Okay, so.
But what's great, though, is that you can leverage a lot of the default implementations for things, right?
Yeah. So that is great, and we'll show that in a little bit. And I am not going to live code the creation of the endpoint. So we looked at the endpoint and the route endpoint stuff earlier. So the route endpoint is that class that derived from endpoint that adds the route pattern that we just looked at a minute ago. I'm creating a new one of those. I'm writing a, let's move this. You know, I didn't even notice the magnifier this whole time, by the way, guys, that was open. But anyway, so we're doing up a route endpoint with that request delegate that writes the display name with the custom endpoint ID. We're giving it a path to match, custom ID. And then order, right? Since all the endpoints like run in the same middleware, like what order you call map get, map post doesn't matter. Map fallback works by basically setting this property on the endpoint. I always forget whether it needs to be negative or positive to give it lower precedence, but you can look that up.
So by default, is it always 0?
Yes, 0 is the default, which is why I chose it. So that means that like if you were to call map get with the same route pattern, instead of hitting one of those endpoints, you're going to get some sort of like 500 conflicting endpoints defined. You might have seen it in your apps. But you can get that even with a custom data source. So if I now return some endpoints that I create, so I'm just going to do 2 because every single one takes time. I had like a link version, right? You can imagine numeral.range, like select. You can do that too, but like I'm not trusting myself. And then we can do app.datasources, which doesn't exist because we implemented the iRoute endpoint builder interface explicitly. So that means that methods like mapget that, oh, please. Yeah, so that extend I endpoint route builder. Yeah, there's my problem.
Wow.
Again, yeah, you know, there's a lot of words. This is an advanced API.
And we're known for our lengthy API names.
Yeah, and like I've been doing more API review recently, so you can blame me. But this was before my time. And so bad. I should be moving on. Okay, is it too late? The iRoute endpoint.
Oh, we went back to that.
Oh my goodness. All right. Well, you know. Yeah, take it over. Take it over. Take it over.
We did it!
Oh
Yay!
my goodness. All right, so we'll take a quick look. We'll take a quick look since we did it. All right. Let's run it. Let's see if it works. Cross your fingers. Extra emojis.
Everything's crossed.
I keep on hitting the function key because like I just turned that off on this laptop because I'm like, oh, I'm never gonna remember to hit now when I hit the function key. That's the story. Anyway.
So while this is building, one key thing to note here is that app actually implements quite a few different interfaces, right? And here you're targeting the iEndpoint route builder. You talked about iApplication builder earlier.
Yep, and I'm missing a parenthesis, so take it over.
All right. I'm going to segue a little bit here now that Stefan has given us a deep dive into endpoints and talk about a feature that we introduced. Did I do that right? Okay. There we go. Now I did it right. I'm going to segue from that introduction into endpoints and talk about a feature that we introduced in .NET 7 that builds on the endpoint feature in ASP.NET, and it's endpoint filters. So endpoint filters are pretty similar to action filters in MVC if you've used those. They essentially allow you to write code that can introspect and modify arguments and also intercept the response in an execution pipeline. So I have an example that demonstrates that here. I've got a minimal application as well. It's that Hello World sample that Stefan showed earlier, but I've done a few modifications on it. I've introduced a name route parameter in my route here, and that's mapped to a name parameter in my handler, and this handler here is just going to print out hello name to the user. Now, what's special here is that I'm invoking add endpoint filter factory. This is a new extension method that's shipped as part of our APIs in .NET 7 to register an endpoint filter. Now, I want to go through the code that's happening in this filter really quickly so we can kind of get a sense of some of the different types and things that are going on here. All right, so the first thing I'm going to observe is that it looks like this method is returning a delegate. Okay, that's kind of interesting. So this is a function that returns a function, and the particular signature of the function that it returns looks like it's taking an invocation context. Cool. And in addition to an invocation context, it looks like there is another context object that I'm interacting with here, and I'm able to read the method info. Here's a sneak peek. This is the method info associated with the route handler that is registered on this route. So this method info, if I access the parameters that are available on it, I'm going to get information about the string name parameter that's defined on my handler. And here I'm writing some logic that essentially says, get the parameters in this current handler. If there is one parameter that's defined that happens to be a string, then I'm going to return a filter that is going to modify that string argument. I'm going to be uppercasing it, and then I'm going to call the next filter in my execution pipeline. So we've kind of got a couple of concepts to play with here. We've got this endpoint filter factory concept. We've got this notion of functions that return functions. We've got two context objects that we're interacting with, one that gives us access to method info associated with a route handler, and another that seems to be specific to an invocation. Cool. So I want to dive a little bit deeper into what this add endpoint filter factory function is doing. So let's take a look at that definition. We'll F12 into it. We are now in framework code. You can find this, as Stefan mentioned, it's open source. We'll spot a couple of things here. The first is that it looks like this extension method works by adding the filter factory, that's that function that returns a function, to the list of filter factories on an endpoint builder. Stefan alluded to endpoint builders earlier, and one of the things we'll observe is that this filter factory property is defined on the base or abstract endpoint builder. This is the endpoint builder that all different types of endpoints build on, whether they're controller actions, route endpoints, endpoints derived from Razor pages. This is the base implementation that they're going to use. And this is really important to note because the fact that this property is defined at such a low level in the framework opens up the opportunity for endpoint filters to be supported not just for minimal APIs that use route handlers, but endpoints that are derived from MVC controller actions or maybe Razor pages. So that's kind of like a sneak peek into something that I'll allude to a little bit later, but this design choice kind of guided us in a particular direction when we realized it. So cool, that's one thing I wanted to note there about these endpoint builders. Another thing that we'll note if we go into this endpoint filter factory again is the fact that it's taking an endpoint filter factory context. There are a lot of context objects that we use and types that we use in ASP.NET. This particular one is accessible to you if you are defining a filter factory. It gives you access to the method info. That's pretty important. It tells you this is the handler that's going to be invoked when you're writing your code. It gives you access to a service provider, so you can access anything that you have in dependency injection. One thing that's missing here and is an important part of endpoints that Stefan alluded to earlier is metadata. You can't access metadata in this endpoint filter factory context, at least as of RC2. As of Preview 7, you could, and that's because we had a 1 hour, 40-minute discussion about whether or not metadata belonged here. We also ultimately decided it didn't. We'll talk a little bit later about what direction we went into and why we made that design choice. So cool, those are kind of the things that I want to capture as part of this exploration into the endpoint filter factory. Now, one thing that I mentioned is that these filter factories are registered or stored on each endpoint builder. That makes me think that they probably participate in endpoint construction in some way. That's the whole process that Stefan was alluding to earlier that happens as a part of routing. And in fact, they do. Filters come into play when we construct the request delegate that is associated with our endpoint and map to that route handler. So here I am in the route endpoint data source. Stefan was showing this file earlier. I've zoomed in on a particular portion of it. You'll notice we've got an if statement that checks to see if we have any filter factories registered on the builder. If we do, it's going to pass them along to this little entity called the request delegate factory. Now, as the name suggests, this is like the thing that is responsible for taking a delegate that represents a user's handler and converting it into a request delegate. It is an extremely large class. We talk all the time about breaking it up into smaller pieces. We haven't gotten quite to that yet.
I have a PR.
He has a PR, so it might be coming soon. Before we dive into the code, I wanted to really quickly segue into another Excalidraw that I created that'll kind of give us a mind map to work with as we explore the code of the request delegate factory a little bit further. So again, what's it responsible for? It takes a delegate that looks something like this. This is the signature for my handler. It takes a string called name and returns a string. And I expect it to spit out a request delegate, which, as Stefan showed us earlier, takes an HTTP context and returns a task. So somehow we have to marry the two together. And what essentially happens is that this gets broken into a 3-step process that I've color-coded and outlined here. Nope, don't want to do that. The first step that happens is known as parameter binding. This is the phase where we marry the parameters that are defined in method info with the parameters that can be accessed from the HTTP context. So in this particular scenario, I have a parameter called name that is defined on this handler. It happens to have a type of string, and I happen to know by examining the route pattern that's stored in the endpoint that it is also in the route parameters. I can make an assumption then that I probably want to resolve the value of the string parameter from the HTTP context route value dictionary. So that's the kind of binding or resolution that happens for that particular parameter. There's a lot more nuance to it for different types and a little bit more complexity, but that's kind of the gist of parameter binding that we'll use to dive into this. The next relevant point to talk about is filter factory invocation and the construction of the filter invocation pipeline. That's kind of how we refer to it in the code. And that's essentially the idea that we have this user's route handler. That's the core code that needs to be executed by the user. And we have a collection of filters that need to run around that in a nesting doll fashion, very similar to what happens with middleware. So you can think of like the concept of execution flow is the same between filters and middlewares. And what we essentially need to do is we need to implement some code that is going to take that user's route handler and map it to a delegate that fits the signature of endpoint filters, which happen to take an invocation context and return a value task of object. So we got to do some mapping so the signatures match, and then we invoke each filter factory that we have on the builder, get the endpoint filter delegate that it returns, and build a chain that we will start invoking. The net effect of this is that you end up invoking the filters in, well, I think the best description for it, Stefan, is last in, closest invoked. And what I mean by that is that the last filter that you register on endpoint is the one that gets invoked closest to that particular handler. So let's take a look at what that looks like here. Scroll back to content. I feel like I'm floating in free space. Where's my cute little thing that I did? Oh, here it is. There you go. Okay, so this is a visualization that I pulled off to the side to showcase what's happening when you register multiple endpoint filters on a endpoint. So I've got A, B, and C. I'm invoking some code that gets called before the invocation of next and after the invocation of next. And you'll see that C, the last filter I added on my endpoint, is called right before my handler is invoked. And it's also the first thing that gets called when my handler returns. B is called before C on the way in and after C on the way out. A is called before B on the way in and after B on the way out. So you get that nesting doll style that we were talking about a little bit earlier. So that's the construction of the invocation pipeline. Once we've constructed the invocation pipeline, we actually want to go through and call it. One of the things that we need to do here is provide it with a filter invocation context. That's that context object that's going to give us access to HTTP context and to each of the individual arguments that are in the handler. Once we have access to it, we can invoke it. once we've invoked it, we are probably going to get some response out of it. In our particular case, it's going to be that value task of object. And we need to figure out how to write that to the HTTP context response. And so we've got some logic that will write that out into the response. Now, what I've shown here is kind of visualizations and some like pseudocode that I've written. What the request delegate factory is actually doing is building out expression trees using LINQ, which makes it so much fun for us to debug when we're trying to work in this area. So as I hop into the code here, you're going to see that there's a lot of LINQ expressions being produced.
Why not a Roslyn source generator?
Oh, we have some limitations that prevented us from using Roslyn source generators. We're actually working on a prototype at the moment to evaluate if source generators would be a good option, especially because they make it a lot easier to support trimming of these minimal APIs. So heading back in, now that we've kind of got a landscape to use or map to guide us through this landscape, we know there's going to be parameter binding, we know we're going to have to build a filter invocation pipeline, and we know we're going to have to write out responses. We can actually step through the code with a little bit more confidence. So what I'm going to do is I'm going to set a couple breakpoints here. I'm going to set one inside my endpoint filter factory, and then I'm going to set one inside the filter that it returns. So let's go ahead and do that. And I'm going to go ahead and start debugging my application. So my application is running, but no breakpoints have been hit. Why? Well, it's because I haven't visited any of the endpoints yet. So I'm going to go ahead and do that. And what will happen there is we're going to go ahead and trigger the routing middleware. So I'm going to hop into my API handler here. I'm going to click send. We've hit a breakpoint. What just happened in the background is routing lit up, said, hey, I need to figure out what all the endpoints in the application are so that I could resolve this incoming request I got. And as part of that, it's going to go ahead and build those endpoints. And here we find ourselves in that point of code that I talked about a little bit earlier, where we're actually calling the request delegate factory. If we step into it, we'll observe that one of the first things we do here is actually create the arguments or process the parameters that are in the method info and try and figure out where we can resolve them from in the HTTP context. So let's step in here and see what that looks like. All right, so we're inside the code that examines or reflects on the method info and looks at the parameters and then produces LINQ expressions. So for example, we might say, hey, if we see that you've annotated a parameter with an attribute like from route or from query, we're going to produce a LINQ expression that says, look at the route values for a parameter of this name. And we have a ton of different heuristics that do things like look for explicit attributes. There's also some smartness that tries to resolve things that might be in services or a request body. We look for things that have a try parse that we can enumerate on. So there's a ton of binding rules that we can execute here. What I want to particularly hone in on, though, is the binding rule that gets invoked when we run our code, which is going to go ahead and see, hey, we've got a string, and it looks like that string parameter's name also exists in the route pattern. So I can make a mapping between the two. That's that same thing I mentioned earlier. And I'm going to produce a LINQ expression that represents that binding of that parameter from route values. So there you go. We've bound the argument. Of course, a lot more logic happens depending on what types you use for your parameters, but that's kind of the gist of it. The next step is that we actually need to construct the filter invocation pipeline now that we have all of the arguments. What we're going to do is step into it here, and you're going to see the exact breakdown of tasks that I mentioned earlier. The first thing we're doing is we're taking the handler and we're mapping it to a signature that matches endpoint filter. So we wrap the return to a value task of object. We make sure that the invocation is accessing our HTTP context that's accessible via the invocation context on the filter factory. And then we do the filtered invocation itself. Now, Stefan, you might notice that there's kind of an interesting expression here. It looks like there's a condition that is evaluating the status code. And if it's 400, we don't invoke the handler. And if it isn't, then we do invoke it. So this is actually something that's really important to note about the invocation order of these things, is that binding happens first. Binding might fail for some reason. For example, if there's mismatched optionality, you say that a parameter is required, but you don't actually provide it in the request. When that's the case, your status code on your HTTP context gets set to a 400x. Your filters will still run and be able to examine that 400x status code, but your route handler will not. So this is kind of interesting behavior that we discussed, because we were like, well, does this mean that filter should be able to figure out how binding failed, and like how detailed do we want to go into this? But that's kind of something important to know as you're implementing filters. It's an implementation detail that'll kind of affect the behavior of those filters. So once we've constructed the core handler, we can actually go ahead and build that nesting doll model of filters around it. We do that by going through the endpoint filter factories, invoking them in reverse order. Now I'm going to step through into the next line of code, and we're going to see something happen, which is we've jumped back into our application code. We are now back in our filter factory because it's getting invoked at the point of endpoint construction. That's what we expect to happen. And if we dive back in, we'll see that after our endpoint filter factory has been invoked, return that filtered invocation, we get that entire pipeline out to us in the request. So cool, we've processed our parameters, we have constructed a filtered invocation pipeline. Now we need to call it and write out the responses. Now, one of the things you'll notice is that we actually call out to a method here to create the endpoint filter invocation context. And that's because we decided to make a little bit of an optimization in .NET 7 to the way that filter invocation context is constructed. So I'm going to step into the code and talk a little bit about this perf optimization. Cool. So we'll go through and talk about what happens if you have more than 10 arguments in your handler. 10 is kind of an arbitrary limitation. So if you find yourself writing APIs that need more than 10 arguments, let us know, and we'll add support for more. But if you're not, we have this default endpoint filter invocation context. So if we step into that, we're going to observe two things about it. The first is that this is allocating a list to maintain the arguments or the values of the parameters that were provided as part of the request. The second thing we'll notice is that it expects these to be objects. And we have them as, so what we'll have to do is box them as we construct this default endpoint filter invocation context. Now, we were thinking through ways that we could avoid this allocation of the list and also avoid having to box them whenever we instantiated this context object. And what we decided to do was produce these generic implementations of endpoint filter invocation context that support up to 10 arguments. And how they work under the hood, if we pop into one of them here, you'll see that they take a generic that represents the type of each of the parameters that are in your handler, and these are stored as properties, so you avoid the list allocation of the list arguments object, since each value is a property on that invocation context class. And then you'll notice you also avoid the boxing when you have to actually instantiate them. So this is a performance optimization that you get out of the box. As long as you're not using more than 10 arguments, or you are not compiled under native AOT, there is actually a constraint now because you can't statically analyze generic instantiations like the ones here. Since we generate this code dynamically, native AOT does not like this very much. So in those two scenarios, you can take advantage of this performance optimization, but we hope that in most cases you kind of get the benefit of it.
That's a lot of work to save array allocation and some boxing.
You know what? That's what happens when David Fowler is your architect and he really milks performance out of it. But you know, it's so fun that we kind of get to work on all these little optimizations. Now, we're getting very close to the end here. We have found our parameters. We have created our filter pipeline. We've invoked it with a invocation context that we've constructed. Now we actually need to write out the response. And there's essentially a pretty straightforward path that we take here, because when you're operating with endpoint filters, you know that your response or the result is going to be a value task of object. So we have some code in the request delegate factory that looks at the return type of the handler and says, hey, if you're a string, I'll probably write you out this way. If you're something that I need to serialize as JSON, I'll probably write you out this way. And if you're a value task of object, I will process you this way. And so you'll observe that because we're working with an endpoint that has a filter, and everything gets mapped to that endpoint filter delegate signature, we call the path that takes or processes a value task of object. Now, up until this point, we've basically just been building expression trees. It's expression trees everywhere. We haven't actually compiled anything. We do that here, though. There's this function that is going to do some handling of the request body that kind of happens a little bit closer to the compilation, and it'll compile the actual request delegate from these link expressions that we've been building that do parameter binding and response processing and all of that good stuff. So I'm going to go ahead and click continue, and something very exciting is going to happen. Almost. Here we see that we've got our returned or constructed request delegate. So we've taken the user's handler and we've mapped it to something that fits in with that pipeline that Stefan showed us earlier. Okay, this is the interesting thing I was looking forward to. We're in the endpoint filter. What does that tell us? It tells us that we made a request delegate. The routing infrastructure has already routed to it. It's identified that this is a route pattern, or this is the delegate that matches with that route pattern. And it's now running that filtered invocation pipeline that we've constructed. All of the magic has worked. The demo has worked. So if we continue through here, we're going to step out of that code, jump back into my API tester, and you're going to observe in not so bigly font that you can see hello Sophia has been printed with Sophia in capital letters, which was the task of that endpoint filter. So that is pretty darn sweet. You've kind of seen the end-to-end of how these things get constructed and invoked. Endpoint filter factories get called once during endpoint construction, and your filter is going to get called every time you hit that endpoint. Now, Stefan, I'm kind of excited to take this a little bit further. I envision myself having a greetings startup with all sorts of hello and bye and in different languages, all sorts of greeting-related endpoints. But I feel like I want to be a little bit more organized about them, and I think you might be able to help me with that.
Absolutely. All right, can you switch me back, Sophia? So I think filters are one of the highlight features in ASP.NET Core. I don't know how much Sophia mentioned it, but not only does it work with the request delegate factory, you can use it with MVC controllers, and the design of filters ended up designing or affecting this design of a new method that we've created called MapGroup. So we noticed some feedback after releasing .NET 6 that people are I can't organize my minimal route handlers the way I could with the controller. I could just add some attributes at the top of my controller, and I don't have to repeat myself calling require authorization every time. For this example, I'm going to create a preview version of the APIs we were just looking at. So I'm going to add a preview prefix. Now, an interesting thing about MapGroup is that it implements that route endpoint builder. I think I said it the right order. Or rather, it is an extension method for that type. And then the type it returns also implements it, right? So you can call MapGroup on MapGroup. So if I wanted to, I could do MapGroup preview 2 as well, right? And all of these, you can restore the return value, have different layers, all that. This takes a string or a route parameter, but you get the idea. It's a lot harder when you're coding live. This is why I just jumped to another commit. I mean, I raced while Sophie was talking, and I wrote this all clearly.
That was pretty impressive.
You can tell
totally
how much I
used.
Yeah. So this is just using extract a method feature that we were looking at earlier. This has the filter factory that Sophie was working on. We added a buy controller. There's that data source we had earlier. Another thing that I wanted to point out, wanted to get at the beginning, but I was already tough for time, is that endpoint data source is a service. So there's a composite endpoint data source that basically does a select many on all the data sources you add and adds the endpoints, and then you can see them all. So that's what I've added to the root, is like this is just writing, this is using dependency injection. That's a feature with route handlers. You can just, anything that's in the service container, you can add it. And so this should allow us to see the routes that we've added. So with this preview, basically, the only difference between the root, like app, and this preview area is that I've added metadata, and this takes like any kind of object. In this case, I chose string. You should create your own object type so it doesn't conflict when you do something like this. So typically in something like middleware, right, you would call context.getEndpoint. It's like the same thing that useRouting is calling to look for the route pattern and so forth. And then you can read the metadata and use it. So I'll just show you what this looks like pretty quickly, just like what that means, hopefully. And anything? All right. Yeah, so there's the list of endpoints we're looking at. Those were, we added the custom endpoints earlier, and that totally worked in the first part of the session. And then, right, now that I've added that metadata, if I go into the preview group, right, that changes like the response that's output. So you can use that for like feature flags, things of that nature. If you want to have, a part of the site that's authenticated, part that's not, like these are a good way to use groups. So a question then becomes, how does this work with filters, for example, right? So filters can extend any what's called iEndpoint convention builder, which is the other interface that preview, or in this case, the map group implements. And then we can add the endpoint factory, and this will now affect only the preview endpoints.
Nice.
Yeah, so hopefully we don't have more demo fails, which is a lot to assume. We will, because yeah, you notice I changed the code there. So like, I was testing everything before I came back
that
on.
Are misaligned.
Yeah, clearly it's a solar flare if I mess this up. So if I say like, hello, Safia, this is not preview, so hopefully there's like no uppercase. And
Nice.
then if I preview it, I'm like, I think people want to know how excited I am to say hello. And it's like, maybe you can A/B test that. Oh, that's going to work good. So like filters work. They also work for controllers. So one thing that I kind of glossed over at the beginning here is we have like a bunch of endpoint data sources we implement ourselves from apt-get, controllers, Razor pages. Filters work on things that take things that look like methods, right? So right now, at least, they don't run on Razor pages. They do run on controllers because we have a method we can call. Same with route handlers. They're similar enough that we decided that we wanted that kind of parity. It's also been a design decision we've thought about, like how breaking would it be if we like added support for filters to say Razor pages after the point, especially since you can like apply filters to an entire group. We're worried that would actually be pretty bad. But anyway, so for the default implementation, so you'll notice that custom endpoint data source, I added a get group endpoints and then just called base. But that is to demonstrate basically how the map group interacts with, okay, add breakpoints, please, the endpoint data source. So I'm going to restart this, and you'll notice that first, hopefully, we are going to hit some sort of breakpoint. So another interesting thing is like the endpoints are lazily resolved the first request that hits the endpoint routing middleware, and then they're cached. So we're fortunately like not rebuilding link expression trees every request.
Yeah, that's what we were seeing earlier with the filters demo. The factory gets called once because you.
Yeah. Unless you fire this change token, which is like super advanced, and then you can make it reload the endpoints on whenever you want. But none of our default endpoint data sources do that. But that is a cool way to like dynamically add endpoints and stuff. That will rerun all the filters because like your endpoints have changed. So something to be aware of.
Right.
And
with 45 seconds left.
We're done.
Is there anything we want to take you all out with? Hopefully, this introduction gave you an appreciation for some of the design considerations we take in when we're building out these features as a team. We love your feedback. Please try out previews. Let us know how we're doing. We love iterating on our designs. You can interact with us on the .NET ASP.NET Core repo on GitHub. You can also find Stefan and I on Twitter. Our socials are all there. We're short on time, but we're going to be out in the corner if you want to ask us any questions or maybe dive into more of the code with us here. Thank you so much for joining us.